Now, if we take description of the modern periodic table, in fact, now also we are using different periodic table, but most commonly that we are using is the long form of the periodic table. In the long form of the periodic table, what we have some basic description. We have in this case 18 vertical columns, which are called as groups, which can be taken, number can be given as 1 to 18, latest. Earlier they were also named as subgroup A and B, like we have 1A, 1B, 2A, 2B, means we have 1 to 7 as taken A and B subgroups, and then we have one group 8 and one group 0. We have 9 vertical columns. I'll explain to you this in the periodic table when you draw some outer sketch only. Or we can take as latest taken 1 to 18 is a sequence. We will take left, extreme left is group number 1, then 2, 3, 4, 5, 6, 7 up to 18 we have vertical columns which are called as groups. We have 18 groups in the periodic table. In subgroup they were taken as A and B subgroup 1 to 8. We were having 8 groups separate and group 0. We'll explain the similarity कि कौन सा A और B था, 1 2 में क्या relation है उनका आपको बता दूंगा मैं. अगला क्या था, we have 7 periods. The 7 periods can be taken as very short, long or very long period depending they contain how many elements. We can take first period have 2 elements only. We have hydrogen and helium. It is called very short period, only 2 elements. Then second and third periods are called short periods. Second have element from lithium to neon, and third have element from sodium to argon. They each contain 8 elements which are called as short periods. Then we have long period. Fourth period is called as long period in the periodic table. Fourth period is called long period. A long period in the periodic table, it have 18 elements. In fact, 4 and 5 both. They are called long periods, each containing 18 elements. Then sixth period is called very long period. It have 32 elements. And then we have seventh period, very long but incomplete. Till now 114 elements have been given the names up to 114. So we can take it is incomplete. Seventh period is incomplete, and it is given just write incomplete only. Now you can take here we have 2 separate blocks are assigned for the lanthanides and actinides. They are placed at the bottom of the periodic table. Lanthanides are placed in the 6th period. They follow lanthanum. In group number third they will follow, and actinides they will follow group number third element taken actinium, and they are placed in the 7th period, but not in the period directly. They are placed at the bottom in separate columns. Okay, so we will explain that also to you. Now some property of elements can be taken. Elements depending on this periodic classification. See, these elements have been placed in separate groups in which the element which are having similar electronic configurations, element having similar electronic configurations are placed together in same group. So what happens when the same group have elements in similar electronic configuration? The properties resemble. In fact, the properties of elements will depend on their electronic configuration, because that decides what is their tendency to lose electrons, form positive ions, or to gain electron, form negative ions. What is the nature of elements? It depends a lot on their electronic configurations. So we taking properties. First property can be taken valency. For the elements, valency can go from 1 to, we can take 7. Valency can go from 1 to 7 if we take valency of elements with respect to oxygen. With respect to oxygen, the elements valency can increase from 1 to 7 in the period, along the period. However, if we take hydrogen is taken for reference, then the valency of element increase up to 4, and then it decrease again from 4 to 1. So valency increase from 1 to 4 up to middle, and then again decrease from 4 to 1 if hydrogen taken as reference for the elements valency. Next taken metallic nature of elements. In the entire periodic table we have maximum number of metals, and in fact when you take metallic nature of the elements will be increasing on moving down the group and decrease on moving along the period. If it is taken extreme left in the periodic table, we have all metals. Extreme right, we have mostly non-metals. And moreover, this metallic character also decreases on moving along the period and increase on moving down the group. आपको जब पढ़ेंगे ग्रुप थ्योरी तो आप उसमें देखेंगे इस चीज को है कि हाउ दिस मेटेलिक नेचर चेंजेस. अगला पॉइंट है इलेक्ट्रोपॉजिटिव एंड इलेक्ट्रोनेगेटिव नेचर. Electropositive nature means the tendency to form positive ions by losing electrons. So on moving along the period, the tendency to lose electron decreases. So what happened to electropositive character? Decreases. While moving down the group, the tendency to lose electron increases. You will see the variation factor affecting ionization enthalpies, which describe this property. So on moving down the group, electropositive character increases, while it is reverse in case of electronegative properties, electronegative nature. The electronegative nature of the elements, it increase on moving along the period and decrease on moving down the group in general. Then we take oxidizing and reducing nature of elements. When we take the element oxidizing and reducing nature, that what is meaning of oxidizing nature? The tendency to gain electron and get reduced. Then the compound can act as oxidizing nature, oxidizing agents, and the substance which can help in reduction by losing electrons, they can act as reducing nature. So on moving along the period, the oxidizing property increases, the strength as oxidizing agent increases, while on moving down the group, the strength as reducing agent decreases. The strength as reducing agent decreases. I hope it is clear to you, these 2 points. Now we can take some more property here, I'll write here. Now next property can be taken this elements, nature of oxides. If we take the nature of oxides of elements, we can take from, let's say, group third period elements, sodium oxide, magnesium oxide, Al2O3, silica SiO2, P4O10 या P2O5, SO3, Cl2O7. We have all oxides taken of the elements. Elements of first group to second, third group number taken here. Means it is 13 group, 14, 15, 16, 17 group elements. So we can take the given oxides nature wise. First two are basic in nature. Al2O3 become amphoteric in nature. Amphoteric means which can behave as acid and base both. With the strong acids, they will behave as base, while with strong base, they will behave as acids. Then this remains silica, silicon, phosphorus, sulfur, chlorine, all these elements form acidic oxides. And you can take here in this series for oxides, acidic strength increases. Acidic strength increases. Depending on oxidation number, if you take redox reaction oxidation number, or we can take valency wise also, can take simplified way, sodium plus 1, magnesium plus 2, plus 3, plus 4, plus 5, plus 6, plus 7 are the oxidation number of valencies of the elements. When the oxidation number or this valency is increasing of the elements, then what happened to acidic strength? It increases. If for different elements, this strength, it is directly proportional to oxidation state. In general, always, what is, we don't use the word always, but in general, mostly when we take different elements in different oxidation number, then generally higher the oxidation number and elements more electronegativity, they will form more acidic oxides. More basic oxides are formed using the metals in low oxidation number, or more electropositive elements form basic oxides. Now next property can be taken here, diagonal relationship. Diagonal relationship. What is diagonal relationship? Details with properties we will study later on when we take S block elements. So what is definition? You can write down, write down. It is similarity in the properties. It is similarity in the properties of the elements. Similarity in properties of the elements of second period. Of the second period with the elements of third period of next group. Similarity in properties of elements of second period with the elements of third period of the next group present diagonally opposite. Present diagonally opposite. Like if I take the elements of second period, lithium, beryllium, boron, carbon can have, or more can take, but resemblance keep on decreasing from here to that side. We have sodium, magnesium, aluminium, silicon. If it is nitrogen, we have phosphorus. So what actually happens, or what is observed here, that the elements of the second period, it is the element of second period, it is element of third period. The properties of element of second period resemble more to element of third period, present or coming diagonally opposite. Why it happens? If we take brief idea that when we move along the period, what happened to elements? Tendency to lose electron decreases. While moving down the group, the tendency to lose electron increases. So element coming here will have similarity in properties. Thus elements of the second period resemble element of third period of the next group coming diagonally opposite. That the similarity in properties of element is called as diagonal relationship. It is some brief idea about this. Some properties, resemblance of the elements or properties studied by variation in the modern periodic table. Okay, let us take the relation of periodic table subgroup A and B and group number 1 to 18. Now it is taken the long form of the periodic table, or we can take modern periodic table. In this case we have taken group number 1 to 18, where the vertical columns are called as groups. I am not writing the elements here. I write some element for your reference, but you try to write this entire periodic table later on by taking good source for writing this elements. It is taken group number 1, 2, 3, 4, 5, 6, 7, 8, means up to 18 we have groups, and then we have this, they are taken vertical columns are called as groups, and the horizontal rows are called as periods. We can take first period have hydrogen and helium. If I write here some element like we have hydrogen and helium, we have in this case second period we have element lithium, then we can have beryllium, we can have in this case boron, carbon, nitrogen, oxygen, fluorine, neon. If we take in third period we can have elements sodium, then we can have magnesium, we can have here aluminium, silicon, phosphorus, sulfur, chlorine, argon. In fact, if we just taken fourth period elements, we can have potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Then we have gallium, we have then germanium, arsenic, selenium, bromine, then we have this case krypton, the next noble gas. In fact, all the elements you can memorize, but at least try to keep in mind 36 elements atomic numbers. So it is taken the element up to first 36. We can have then group taken, it can have sodium, potassium, rubidium, cesium, francium. We can have this case elements strontium, barium, radium, and so on. तो I'll give some tricks to memorize the elements in the separate groups. कि कैसे शॉर्टकट होता है याद करने के लिए आपको बता दूंगा उसमें पूरा, इसके लिए भी और पी ब्लॉक एलिमेंट्स के लिए भी. तो ये आपका वो लॉन्ग फॉर्म हुआ यहाँ पे वो एलिमेंट होते हैं लैंथेनाइड्स, दे फॉलो लैंथेनम, सो वी कॉल देम लैंथेनाइड्स, स्टार्ट फ्रॉम सीरियम टू लुटेशियम, एंड दे विल फॉलो एक्टिनियम, 89 atomic number from thorium to lawrencium, Lr. These elements are called as actinides, which follow actinium, 89 atomic number, thorium is 90 atomic number to lawrencium 103, cerium is 58 atomic number to lutetium 71 atomic numbers. And it is taken from here. We can take in this periodic table, if I take some ideas of A and B subgroups, if I take here first A, I'll let next slide. आपको I hope it is clear. See, for lanthanides and actinides, there is no separate group. All the elements of lanthanides are placed after lanthanum, in third group, or after actinium of the third group again. For these elements, lanthanides and actinides, separate groups are not assigned. We are all following lanthanum or actinium of group number third only. Okay, so group third 1 to 18 we have group numbers, 1 to 7 we have periods number. First have two elements, second have we call short period, shortest very short period. These are having 8 elements each, we call them short periods. Fourth 5 they are having 18 elements each, we call them long periods. Group number 6 period have 32 elements, 18 here plus 14 here. That 18 plus 14 become 32 elements. And then 7th period is incomplete. If it is fulfilled, this also will contain 32 elements. Okay. Now what the relation of A and B subgroups? Let us write that also. If I take in this case, group number 1A is same as group number 1, then 1B is taken group number 11. Then you can take here 2A is taken group number 2, 2B is taken group number 12. Then you can take here 3A same as 13, 4A is 14, 5A 15, 6A 16, 7A as 17. Group 0 is group number 18. Then B, if I take subgroup B, it is taken 3B. 3B is taken group number 3rd, 4B, 4th group, 5B, 5th group, 6B, 6th group, 7B, 7th group, group number 8. It is taken group number 8, 9, 10 together. Group number 8, 9, 10 together are taken as group number 8. It is 1B, 2B, 1, 2 is taken 1A and 2A respectively. 11, 12 taken 1B, 2B respectively. They are all taken A's 13 to 17. 3rd A, 4A, 5A, 6A, 7A. Group 0 is taken noble gases. Group 18 is called as noble gases. Noble gases. If it is taken, this element taken here are called as P block elements. P block elements. In P block element, the last electron enter P orbitals. So we call them P block elements. Group number taken 1 and 2. In fact, this group taken all. They are called as D block elements. Third to group number 12. Group third 4, 5 to 12. They are all called as D block elements. Why we call them D block element? Because in them the last electron enters the d orbitals. The last electron called as differentiating electron enter d orbitals. So we call them D block elements. In these cases the last electron enter p orbitals. So we call them P block elements. 1A and 2A, they are called as S block elements. Already we have told you how to write configuration of elements. So group number taken 1A and 2A, or group number 1 and 2 are called as S block elements. They are called as S block elements. And then you can take lanthanides and actinides together are called as F block elements. We take then elements lanthanides and actinides are called as F block elements. I hope it is clear. 1A and 2A or 1 and second group are called S block elements. 3 to 12 are called as D block elements. They are placed between the S and p block elements. For lanthanides and actinides, they are not given in the same periodic table, some positions or separate groups. They are placed at the bottom. In them, the last electron enter f orbitals. So the elements can be said to belong to s block, p block, d block, or f block, depending on the last electron entering which orbitals, which subshell orbitals. If the last electron enter s orbitals, s block. Last electron enter p orbitals, p block. If last electron enter d orbitals, d block. If last electron enter f orbitals, it is called as f block elements. So I hope it is clear. Elements classification in s block, p block, d block, or f block. For the elements, from the atomic number and then writing the elements electronic configuration, we can predict. After writing the element electronic configuration, we can predict the elements group number, block, and the period number. All. How we can predict? Let us explain to you. Now coming on the next topic, prediction of the position of the element in the periodic table. That in the periodic table the element belong to which group, which period, which block. So determination of basically we are doing here period number, group number, and the block. So for writing this element position, we can take here. First for the elements, we write electronic configuration. Means what is the rule here? First write down the electronic configuration of elements. Write down the complete configuration of the element. Then from the configuration, in the configuration highest value of n will give the period number of the element. In the entire configuration we can have 1s2, 2s2, whatever. So highest value of n, where n is taken the elements principal quantum number for last element, or highest value, not last electron, highest value. In the entire configuration, the highest value of the principal quantum number will tell the element period number. Then we can take block, we can decide by this last electron entering which orbital. That's s, p, d, or f block is decided by the last electron entering whichever orbital, given orbital, or subshells. If last electron enter s orbitals, element is s block, and so on. If the last electron enter p orbitals, it is p block elements, or if d or f, so accordingly the elements can be called d block or f block elements, depending on the last electron. Depending on the last electron entering which orbital, we can tell the elements blocks. Next can be taken the elements group number. Now group number depends on the blocks. If it is taken for s block elements, number of electrons in ns orbitals give the group number. We can have two possibilities: ns1 first group element, ns2 element is second group. Only we have two possibilities for the s block elements, because in s subshell they can have only two electron, and these elements are on the extreme left in the periodic table. So we can have ns1 or ns2, ns1 indicating first group orbital, first group element, ns2 indicating second group element. Now take p or d on next point. Now if it is taken for the p block elements, what the group number of the elements? For them the group number can be taken number of electrons in ns and np orbitals plus 10. For p block element, they have general outermost electronic configuration as ns2 np1 to 6. np can have one electron, leaving helium. Helium is left out. It is placed along the noble gas for which the group is given assigned 18, but helium is not exactly p block, should not be taken. Anyway, group number can be taken for elements. It is taken number of electrons in n, s and n p orbitals plus 10. Why 10 we add here? Because before p block elements we have 10 elements of d block. So we have to add 10 for this d block elements which are placed between s block and p block. After s block or before p block, we have 10 element of d block. For that reason we give group number taken is number of electrons in n s orbitals and n p orbitals plus 10. And then we take for d block elements, they have outermost configuration n minus ns 1 to 2, n minus 1, d 1 to 10. So for d block elements, what can be taken group number? It is taken number of electrons in n s orbitals plus number of electrons in n minus 1 d orbitals. For the elements taken of the d block, the group number is equal to number of electrons in ns orbitals plus number of electrons in n minus 1 d orbitals. Add total electrons, that gives the value of group number for the element of d block. And then we take for the f block elements. For them the configuration taken, for them no need of group because no separate group. All are placed group third only, group number 3 only. For these f block elements there is no separate group. If at all we want to write here, we can write them only for the third group elements. They follow active lanthanum or actinium. That is how for the elements we can predict their position in the periodic table. Group number, period number and the blocks. I hope it is clear. Let us take 1-2 practice examples on this concept. Now let us take one question on this concept of prediction of the element group block in the periodic table. How to decide here? I will take 2 examples here to explain this concept to you. Suppose first element taken is silicon. Atomic number is 14. For this element and second element I am writing here is your let's say iron. Atomic number is 26. For these 2 elements, we want to know everything. Their period number, group number and the blocks. So how to predict here? For the elements, the group number or period number. Say first for elements, write electronic configuration. For silicon, what is electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p2. So in this case, highest value of n is how much? 3. So n highest is 3 means it is an element of third period. Last electron entering p orbitals, so it is a p block element. In this case, last electron enter p orbitals, so it is a p block element. And then we can take the element group number. For the p block elements, what is group number? Number of electrons in n, s and n p orbitals, 2 plus 2 plus 10. Element of 14th group. Silicon belong to 14th group. It is a p block element, belong to third period. I hope it is clear. बहुत simple है. Write the configuration, from configuration you can write everything. Now next take an iron. For iron write the configuration first. What is iron's electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. So in this case, what is highest value? The highest value taken of n is 4. The highest value of n is 4. So element of 4th period. N highest 4. So element belong to 4th period. Last electron enter d orbitals. So it is a d block element. Because last electron enter d orbitals. So d block element. And for d block element, what is group number? It is number of electrons in n s orbitals plus n minus 1 d orbitals. So iron belong to 8th group, group number 8, d block, and fourth period. That is how for the elements you can write the configuration. In s block element, we count simply straight away electron in s orbitals. If s orbital have electrons number 1, if s block element have electron 1 in x orbitals, it is group 1. If there are 2 electrons in s orbitals, it is group number 2. That is how for the element we can find the group number, block number and period number. Okay. Coming on next topic, for writing the atomic number of elements which have atomic number more than 100. For them we have a sequence or rules for writing their IUPAC nomenclature.